Assalamualaikum and hello everyone. We are from AS1205E. We'll present to you about metformin in urine by Hplc method. High performance liquid chromatography, or so-called Hplc, is a broad analytical chemistry technique that used to separate compound in chemical mixture. Let's find out about the principles, components and application in Hplc. In our study, we have 5 principles of Hplc, such as the separation based on differential affinity, which based on reverse phase chromatography. The less polar compound elute later. Next, stationary phase. Metformin, being a polar compound, will interact differently with stationary phase based on its polarity. Third, mobile phase, which is the liquid solvent or its mixture of solvents. Other than that, separation efficiency refers to ability of chromatography system to distinguish metformin from other present compounds. And lastly, differential elution. It can be employed to separate metformin from other components such as metabolites. Hplc components work together to separate and quantify metformin from a sample. So, it will start from the mobile phase next to solvent delivery pump, which push the solvent. Next, the column or stationary phase will separate the components sent to detector to detect metformin and generate a chromatogram, and finally, the data system will analyze the result. Hplc have a lot of applications such as pharmaceutical control. In our research field, the purity and content can determine metformin in pharmaceutical formula. Next, biological fields, which is the therapeutic drug monitoring. And lastly, environmental studies. This can detect trace amount of metformin in environmental samples.
Next, we will take a look on the objective of Hplc. Firstly, separation of component. Hplc designed to separate complex mixture into their individual component based on their chemical property such as polarity, size and charge. The objective is to isolate each compound in the mixture so that it can be analyzed further. Next is purify testing. Hplc is used to test the purify of a compound, especially in pharmaceutical industry. By separating and quantifying all components of a sample, Hplc can detect impurities or contaminants, ensuring that product meet quality standards. Lastly is monitoring chemical reaction. Hplc can be used to monitor the progress of chemical reaction by analyzing the changes in the composition of the reaction mixture over time. This allows researchers to understand reaction kinetics and optimize reaction conditions.
Assalamualaikum. My name is BALQIS binti ISAN from Group AS1205E. My student number is 2022840814. Today, I will explain about the methodology part of our research. First of all is the preparation of standard solution. A stock solution of metformin hydrochloride was made using methanol with working standard of metformin prepared in pooled urine at concentration from 1.25 to 50 mg per milliliter. Second method is the sample preparation. In a ratio 1/10 dilution, 100 ml of urine was added to 900 ml of distilled water. Next, up to 400 ml of the sample was mixed with 450 ml of methanol. It later vortex for 3 minutes and centrifuge at 10,000 rpm for 10 minutes. Then, 75 ml of the supernatant was injected into the Hplc column. Further procedure for the Hplc. First of all, metformin standard precision and linearity was assessed by measuring fixed standard over 6 days for intraday and interday variation. Then, the accuracy was determined by analyzing metformin concentration in pooled urine sample over 3 consecutive days. Next, recovery experiment involves preparing non-metformin concentration in pooled urine and calculating drug recovery percentage. Interferences from endogenous compound and various anti-TB, antiretroviral and antidiabetic drug was evaluated using blank pooled urine sample. Lastly, the lower limit of quantification was mathematically derived from standard curve equation with LOD calculated using the formula 3.3 multiplied by O over S.
For the analysis of result, the retention time, the chromatogram shows a distinct peak at approximately 6.24 minutes, which corresponds to the retention time for metformin. Retention time is characteristic of specific compounds under the same chromatographic conditions, confirming the presence of metformin in the sample. The peak characteristics, the metformin peak is sharp and well-defined, indicating good resolution and effective separation from other components in the urine matrix. The absence of significant overlapping peaks suggests that the method is selective and free from major interferences at the return time of metformin. For the baseline stability, the baseline before and after the metformin peak is stable and flat, demonstrating minimal noise and interference from other compounds present in the urine sample. This stability is crucial for accurate quantification and reliable detection of the analyte. Concentration estimation, the height and area under the metformin peak can be used to estimate the concentration of metformin in the urine sample. This requires calibration with a standard curve generated from known concentrations of metformin. The detection wavelength used for this analysis is 233 nm, which is specific to the absorption characteristics of metformin, enhancing its accurate detection. And a smaller peak is observed earlier in the chromatogram, around 1.3 minutes, which could be due to impurities, matrix components, or non-specific interactions. However, it is well separated from the metformin peak and does not interfere with its detection.
Choosing the right solvent is essential in HPLC. The solvent polarity should match that of the sample to ensure effective separation. A lower viscosity is preferred as it allows for smoother flow through the system. Water is a widely used solvent, especially in reverse phase HPLC, due to versatility. Methanol is another popular choice because it works well in many applications and is transparent to UV light, which aid in detection. Stability is also key. We want solvent that won't react with our sample to maintain accuracy. Other than that, decreasing is crucial yet often overlooked steps. By removing air bubbles from the solvent, we enhance the accuracy of our result. Even small details like this can significantly impact our analysis. HPLC offers several advantages. Its high pressure leads to faster separation, resulting in shorter analysis time compared to traditional method. Additionally, it can analyze a wide range of compounds without requiring extensive changes to the method. In summary, understanding these solvent properties is vital for achieving precise and efficient analysis in the lab.